Good morning, I am Professor Ram, and you have come to the Electronics from Scratch course. Today, we will learn how to make a series circuit using the BrightSpark software and Tinkercad. First, we need to draw our circuit. If you haven't worked with circuits before, it might be a bit difficult at first, but you'll get used to it over time. First, let's draw the symbol of our battery. The first thing we need to do is the battery symbol. This battery could be a standard 1.5V battery, or maybe a 5V power supply, or it could be a 9V battery, the square ones we know. So we can vary this battery symbol. After that, we'll add our resistor. The resistor symbol, when your teacher draws it, will look like this, like a spring. This resistor is there to protect our LED or light bulb from being damaged. Next, we'll add the LED. Our LED will be drawn like this. It has arrows on this side to indicate that it is an LED. Finally, we need to close our circuit like this. If we do it this way, we'll set it to 5V, for example. This is the positive side, and the current will flow through here. It passes through the resistor, reducing the voltage, and the LED will light up. Let's see if it lights up. To close our circuit, we'll add the negative part. And that's it, it should light up. Now, let's open BrightSpark. You can find this software easily on YouTube, it's very lightweight and executable, so it shouldn't take long to get. First, let's select our battery. The battery is here. By default, it's 1.5V, so we'll leave it like that. Now, let's find our resistor. Okay, we'll rotate it by right-clicking and choosing Rotate. Great, so it matches the drawing, and then we'll place our LED, either red or yellow. A red LED lasts a bit longer than a yellow LED, so we can see that it stays on a little longer. We'll connect the positive side to one leg of the resistor, then the resistor to the anode, if I'm not mistaken. The anode and this should be the cathode. Exactly, the anode and the cathode, right? Positive and negative. And now we close the circuit. Let's click play. The reason our circuit isn't lighting up as much is because the resistor is 1 kilo ohm, or 1000 ohms, and the power supply is only 1.5V, which is very little. If we increase this, for example to 5V, and click play, we'll notice that the LED lights up a little more, but still not enough. Here we see that the resistor is blocking the current, preventing the LED from lighting up or burning out. To fix this, let's modify it. Commercial resistors are usually 330 ohms or 220 ohms, depending on the case. Now, if we change it to 1 kilo ohm, we'll see that our LED lights up. If it's a yellow LED, it'll light up a little more. We can see that now the LED is on. Now, let's move this circuit to Tinkercad. First, we draw it, then we go to BrightSpark to make sure there are no issues. In Tinkercad, we can't modify the battery to 5V, so we'll set it to 9V to match the Tinkercad settings. But our resistor, if we leave it at 330 ohms, might burn out. We'll add a bit more and change it to 1 kilo ohm to make sure the LED doesn't burn out. So we'll set it to 9V and 1 kilo ohm. Tinkercad is an online platform, very user-friendly. You can register quickly with your regular email account, Gmail, Hotmail, etc. I have my email, so let's start our circuit project. The goal is to make circuits. Let's place a breadboard, test board, here. We can give it a name, but I'll leave it without a name. Next, we'll add a 9V battery. We have batteries of 1.5V, 9V, and 3V, but not 5V, though we have power supplies for that, which we'll discuss in another class. So, let's use a 9V battery. Let's flip it around so we can connect it to the breadboard. Notice here that we have the positive side on top, which connects to the positive part of the breadboard, and the negative side on the bottom, which connects to the negative part. Now, let's add the resistor. Resistors are usually here, but if we can't find them, we can search by name. Let's place the resistor here. Note that we can't place the resistor like this, because this whole line here is energized, and in this case, it would be touching both legs of the resistor, which isn't correct. The energy flows from top to bottom here, and if we place it like this, it would be incorrectly energized. So, we need to flip the resistor around. Now, let's connect the positive side to one leg of the resistor. This is good because the whole section here is energized. Next, the other leg of the resistor will go to the LED. Let's place the LED. The LED also has polarity, meaning it has an anode and cathode, just like we saw in the bright spark diagram. We need to make sure the LED is placed correctly. The leg that is bent is positive, and the straight one is negative. So, the resistor connects to the positive leg of the LED. Next, we connect the negative leg of the LED to the negative side of the battery. We need to make sure the LED is placed correctly. The leg that is bent is positive, and the straight one is negative. So, the resistor connects to the positive leg of the LED. Next, we connect the negative leg of the LED to the negative side of the battery. Once everything is connected, we start the simulation, and the LED should light up. Now, how much resistance did we use? By default, the resistor is 1 kilo ohm. If we change it to 330 ohms, it should work, but we get a warning that the LED might burn out. If we set it to 100 ohms, the LED will burn out, and if we set it to 10 ohms, the LED will definitely burn out. In real life, the LED won't explode or emit smoke, it will simply stop working. It might look a little burned on top, or it might not show any signs at all, but it won't light up. For 9V, I recommend 1 kilo ohm. Let's now continue with series LEDs. First, we'll add the power supply, then a resistor, and finally 3 LEDs in series. This is what we're doing, connecting LEDs in series. We'll place their arrows, then add another LED, and so on. Once everything is connected, we close the circuit with the negative side. We'll test it with 9V, and use a 330 ohm or 1 kilo ohm resistor to see the difference. Let's check this in bright spark first. We'll use yellow LEDs, which look a little nicer. Let's rotate them so they face to the right. Now, we'll connect them in series, LED to LED, resistor to resistor. We can't just stack the LEDs on top of each other, they need to be properly connected. Once everything is connected, we'll see that the LEDs aren't lighting up as much as the first example. If we change the resistor to 330 ohms, it should light up a bit more. Now, let's switch to Tinkercad and create the circuit with 3 LEDs. We can start from the last LED, connecting the battery, resistor, and the first LED. After that, we'll connect the positive leg of one LED to the negative leg of the next, and so on, until we finish the circuit with the battery's negative terminal. Once the circuit is complete, we'll test it. If the LEDs aren't lighting up enough, we can adjust the resistor to 330 ohms to make sure everything works correctly. These are the basics of series circuits. In the next video, we'll build a larger circuit, and after that, we'll move on to parallel circuits. I'm Professor Ram, and if you have any questions, feel free to ask. See you next time.